Here we have a problem on ratio. Let's read the question. If 2s is to 3t is the duplicate ratio of 2s minus p is to 3t minus p, find the value of p square. Here let's consider this particular part. The duplicate ratio of 2s minus p is to 3t minus p. So the duplicate ratio of 2s minus p is to 3t minus p means we are trying to find duplicate ratio of this ratio. So to find the duplicate ratio of 2s minus p is to 3t minus p, what we need to do is we have to square both the first term and second term of the ratio, that is 2s minus p the whole square is to 3t minus p the whole square. Okay, so it is given that 2s minus 3t is the duplicate ratio. That means if we find the duplicate ratio of this one, 2s minus p is to 3t minus p, the answer will be 2s is to 3t. So this is equal to 2s is to 3t. Okay, here some students will get confused. Okay, let's consider the same statement with some other two ratios like 2 is to 3 and 4 is to 9. That is 4 is to 9 is the duplicate ratio of 2 is to 3. Okay, just now I said duplicate ratio of 2 is to 3 means we are finding duplicate ratio of 2 is to 3, that is we have to square both 2 and 3. So this is equal to 4 is to 9. So here the answer is going to be 4 is to 9. The duplicate ratio of 2 is to 3 is 4 is to 9. So the same strategy we have taken here. So the duplicate ratio of 2s minus p is to 3t minus p means we have to find the duplicate ratio of this one. So we square both the first term and second term. When we do so, the result will be equal to 2s is to 3t, because this is the duplicate ratio of 2s minus p is to 3t minus p. Okay, so now in this equation we have to solve for p square. How? So to solve for p square, what we can do is we can write each ratio as a fraction. So it's going to be 2s minus p the whole square divided by 3t minus p the whole square is equal to 2s by 3t. Okay, now what we can do is here we can do cross multiplication. So that is 3t times 2s minus p the whole square. On the right side we have 2s times 3t minus p the whole square. Okay, now we have to expand this one. So this is in the form of a minus b the whole square. So we all know the expansion of a minus b whole square. It's one of an important identities of algebra. So the expansion of a minus b whole square is equal to a square minus 2ab plus b square. Okay, so when we compare this 2s minus p whole square to a minus b whole square, we have 2s for a and p for b. So for a square we have to write 2s the whole square. Okay, let's expand 2s minus p the whole square using this expansion. So 3t times now a square means 2s the whole square, that is 4s square minus 2ab, that is 2 times 2s times p, it's going to be 4sp plus b square means p square, because instead of b we have p. On the right side we have 3t minus p the whole square. So whatever stuff we have done here, the same we have to do for 3t minus p the whole square, because this is also in the form a minus b the whole square. Instead of a we have 3t, so a square means it's 3t the whole square, that is 9t square minus 2 times ab, that is 2 times 3t times p, that is 6pt plus b square means p square. Okay, now we have to multiply this 3t and 4s square minus 4sp plus p square, that is we have to distribute this 3t to all the terms inside the bracket. So it's going to be, when you multiply this 3t and 4s square, you will get 12 s square t and minus 3t times 4sp will be 12 spt plus 3p square t. Okay, it's going to be 18 st square minus 12 spt plus 2 sp square. Okay, in this equation on both sides we find minus 12 spt, so we can cancel them. So we get 12 s square t minus plus 3 p square t equal to 18 st square plus 2 sp square. So we are trying to solve for p square, so we can get all the p square terms on one side of the equation and all the terms without p square on the other side of the equation. So we can get this 12 sp square to this side of the equation, and we can take this 12 s square t to this side of the equation. So we get 3p square t. When I take this plus 2 sp square on the left side of the equation, it will become minus 2 sp square. Already we have 18 st square on the right side of the equation. When I take this plus 12 s square t on the right side, it will become minus 12 s square t. Okay, on the left side from these two terms we find p square in common, so p square can be factored out. So p square is factored out. The first term will have 3t minus in the second term will have 2s. Okay, in these two terms we find 6 st in common, so 6 st can be factored out. When I do so, I'll get 3t minus 2s. Even if you distribute 6 st to 3t and 2s, you'll be getting this one. So we can verify it. So the factoring we have done is correct or wrong. Okay, now my aim is to solve for p square, so I have to remove this term 3t minus 2s. Here 3t minus 2s is multiplied by p square, so if I take this term 3t minus 2s to the right side of the equation, it will become division. So p square is equal to 6 st times 3t minus 2s divided by 3t minus 2s. So we can cancel out this one and this one. We get p square is equal to 6 st. So the value of p square is 6 st.